Alright, so now we're going to look at number 15. So this is chapter 5, part E, number 15. We're going to write our given and find, because a lot of times that's going to help us. So it says, in an electronics factory, small cabinets slide down a 30-degree incline. So I'm going to chunk theta's 30 degrees. A distance of 16 meters to reach the next assembly stage. The cabinets each have a mass of 10 kilograms. Calculate the speed the cabinet would acquire if the incline were frictionless. So I want to find VF. And then it says, what kinetic energy would a cabinet have under such circumstances? It's actually easier to do part B before part A, so that's what we're going to do. But before I even start, I need to picture this. I'm not going to do stuff in my head. I want to conceptualize, what does this look like? So I have an incline, and the cabinet's going to start down at the top. Then it's going to slide till it gets to the bottom, to the ground here. Remember, the ground is our frame of reference. This is base level. So this distance the cabinet goes, this is 16 meters. And they told us that this is 30 degrees. Well, first of all, if we're doing conservation of energy, at the top, we know this cabinet's not moving. So this is all potential. So when I do potential energy, I know potential energy is mgh. It's not mg this distance, it's this height. So I need to figure out what this height is. So this is a right triangle. It's a 30, 60, 90 triangle. I know the hypotenuse. Can I find this side? Yes. So H is going to be the hypotenuse 16 times the sine of 30 degrees. Why did I use sine? Because it's opposite. Sine is opposite over hypotenuse. So H comes out to be 8 meters because we know the sine of 30 is 0.5. So now I know this is 8 meters. Now this becomes a simple conservation of energy problem. So let's first talk about it first in layman's terms. In layman's terms, we know that the total energy before is equal to the total energy after. So the total energy before is the sum of the kinetic and potential. So KEI plus PEI is equal to KEF plus PEF. Now, before I start plugging in and simplifying that, kinetic energy at the top is 0 because it's not moving. So this is 0. The potential energy at the bottom is 0 because it's going to be at the ground where we're going to say that the height is 0. So now we know that 0 plus mgh is equal to KEF plus 0. So the kinetic energy at the bottom is equal to the potential energy at the top. So now I'll go ahead and substitute in that KEF is mgh, so it's equal to 10 kilograms times 9.8 meters per second squared times 8 meters. So that comes out to be 784 joules. And that's why it's easier to do part B before part A. So again, we did conservation of energy. The total energy here is equal to the total energy here. So for part B, it says find the speed. So we're going to do the same thing we did before. The final kinetic energy is 1/2 mvf squared. And now we're going to solve for VF. So I don't have to do 4 intermediate algebra steps like I did before. VF is equal to the square root of 2 KEF over m. I multiplied both sides by 2, I divided by m, and I took the square root of both sides. So now I'm going to substitute in my values. 2 times 784 joules divided by 10 kilograms, and VF comes out to be 12.52 meters per second. Again, the picture is going to help you. The more you write down on paper, the less likely you are to make a mistake, because the picture helps you to conceptualize that. That's it.